Welcome to lesson number 4. We're going to be looking at multiplication of polynomials. Just recall that last lesson we were looking at using the distributive property, also known as FOIL, where we multiply the first term, the outside term, the inside term, and the last term. Now, when we have a polynomial as a plus b squared, we can write this as a plus b times a plus b. So this exponent shows repeated multiplication. And using the distributive property, I would go my first term times my first term, a squared, my first term times, my outside terms multiplied by one another. And again, my inside terms multiplied by one another. And lastly, my last terms. This would simplify to a squared plus 2ab plus b squared. Now, when we apply this, usually we have one variable and then a constant term, and applying this thinking again, or this method of solving a polynomial again, we would have our repeated multiplication, x squared plus 7x plus 7x plus 14 or plus 49, and when we simplify this, x squared plus 14x plus 49. Now there's other types of polynomials, and here we have a difference of squares. So I have 4 minus 7x times 4 plus 7x. When we multiply a polynomial like this, again using FOIL, we would have 16 positive 28x, negative 28x, and negative 49, 49x squared. And our final answer would be 16 and 28x and negative 28x. We cancel each other out, and we would have 16 minus 49x squared. When we're working with polynomials that we need to expand and simplify, we would solve this by first multiplying our brackets using FOIL. So we have 2 times x, resulting in 2x squared, 2 times negative 6, resulting in negative 12x, 3 times x, resulting in negative 3x, and then negative 3 times negative 6, give me a positive 18. We could then simplify inside the brackets again, 2x squared minus 15x plus 18. And then lastly, we need to distribute this 5 into the brackets and multiply everything by 5. And so my 5 into 2x would be 10x squared. 5 into negative 5 times negative 15, we would have negative 75x, and then 5 times 18, we'll have positive 90. I'm just going to set up this equation for you. Remember, this 7p plus 3 squared can be set up as repeated multiplication, like so, and then you can solve just like we solved this last problem, and just make sure you keep that negative in mind. Next we have x plus 5 times x minus 5, subtract x plus 2 times x plus 8. We would carry out our difference of squares, and so where I have my my terms and binomials are identical, but the operation separating them is opposite. So I'll show you a shortcut for solving these types of binomials. We have another one over here. So first of all, if I do it the long way and I FOIL it, I'm going to end up with x squared plus 5x minus 25. And then I would subtract x squared plus 8x plus 2x plus 16. Right, so x squared, 8x plus 2x plus 16. Now, when I simplify my difference of squares here, I'm just going to end up with x squared minus 25, and then I would subtract x squared plus 10x plus 16. Now, if we look at this x squared minus 25, if I just take the square of x and the square of 5, I end up with x squared minus 25. So that's the shortcut, and I'll do it again for this one over here. Oh, sorry, no, this one is not a difference of squares, but on later examples I'll show. Now what we need to do is simplify this, so we'll take it out of the brackets, x squared minus 25. Getting rid of these brackets, I need to remember to distribute this negative sign to all these terms. So that would be negative x squared, negative 10x, and negative 16. When I simplify by gathering like terms, I'm just going to cross out the terms that I'll cancel out. So x squared, negative x squared. And so I'll end up with negative 10x, negative 25, and negative 16 is negative 41. We're going to begin by distributing my 5x into everything in the brackets here. So that'll be my first step. It's distribution, so we would have 15x cubed minus 35x squared plus 5x. Subtract, again we need to distribute by using FOIL, 20x squared minus, I should put that in brackets too, so 20x squared minus 32x plus 15x cubed minus 24x. When I get rid of these brackets, it's going to change all the signs. So we'll have 15x cubed minus 35x squared plus 5x minus 20x squared plus 32x minus 15x cubed minus 24x. When we gather like terms, this 15x cubed and negative 15x cubed will cancel out. I have 35x squared, and I have negative 35x squared. And where's another x squared term? Negative 20x squared. That will result in negative 55x squared. And then this 24x squared. So that will actually result in negative 31x squared. Yeah, so that should have been squared there. And then positive 37x. So given that for every value of x, the polynomial x squared plus 20x plus 50 can be written in the form x plus a squared plus b, determine the values of a and b. Now, we want our equation to be written like this, and this can be written as x plus a times x plus a plus b. Now, if I were to expand this form of my equation, which comes from this x plus a plus b, then this would become x squared plus a of x plus a of x plus a squared plus b, which simplified would give us x squared plus 2ax plus a squared plus b. Now, we're told that this is equal to this trinomial of x squared plus 20x plus 50. Now, we want to determine the values of a and b. Now, if for every value of x, the polynomial can be written in this form, that means that this 2a of x, 2a is actually equal to 20. So this 2a is equal to 20. All right, and so those x terms are the same. And if we solve for our a value, a is going to be equal to 20 divided by 2, or a is equal to 10. For my last term, the positive b value here is coming from a squared plus 50, or sorry, a squared plus b, which is equal to 50. And if we know that a is equal to 10, then we know that 10 squared plus b equals 50, or 100 plus b equals 50. B then is equal to 50 minus 100, or negative 50.